Okay, good morning. Welcome to
MathyMath number 73.
MathyMath73. So this is problem 17 from the 2008
Yeah, I think
AMC
so.
10B. So it's long, I'm just going to read it. Poll shows that 70% of all voters approve of the mayor's work. Okay? On 3 separate occasions, a pollster selects a voter at random. What is the probability that on exactly one of these 3 occasions the voter approves of the mayor's work?
So 70%?
70% of all voters approve of the work.
And is it exactly one?
What is the probability that on exactly one of these 3 occasions the voter approves of the mayor's work?
Well, so you have a 70% chance that the voter will approve.
Okay.
And then you need the other 2 people to not approve.
Okay.
So you're going to get this. Because this is the voter approves. And then the voters don't approve, so cancel a few things. You get 63 over 1,000. But there's 3 different ways you can do this. You have to multiply this by 3.
Okay. Why is that?
Because you can have the first guy approve, the second guy approve, or the third guy approve.
Okay.
And then, so this is 189, which would be 0.189. Is that a choice?
That is choice B, 0.189.
Alright.
Okay. Do you feel good about that?
Yeah.
Okay. And we click and we get that the answer is B. Now this problem gave you a little bit of trouble today. What was the trouble?
Well, I don't think I saw the times 3.
Ah, okay.
I just went with the 63.
Okay. So that's interesting. So what would happen how would you do the problem differently if instead of saying exactly one voter approves,
Or at least
they
one?
said at least one voter approves?
Well, then you'd have to, you can split it up into cases where you have exactly 1, exactly 2, and exactly 3 voters approve.
Okay.
So, this one you had 0.189.
Right.
Well, here you're going to have 49 times, so it's 147 times 3. 0.147 times 3.
Okay. And where did that come from?
Because you have 2 guys, approving and 1 guy not approving.
Okay.
So 7 times 7 times 3, 147 times 3. So that's where you get that. And then all of them approving is 343. Because you really can't switch this one.
Okay.
It's just 0.343.
Right. And so you just, whatever this is, you would just add it up?
Yeah.
Okay. There's actually a different way to do at least one voter approves.
Well, you could have one guy be 70%, and then the other 2 guys, it doesn't matter. Because you already have your 1 voter approving.
Yeah. Unfortunately, that's not going to work. Think about the situation. So this is one way of doing it. You check the number that has 1, the number that has 2, and the numbers that have 3. But there's an alternate way that you can find at least 1.
So, well, you could do it. You can use complementary counting to use where no voters approve.
All right. So how do you calculate how many no voters approve?
It would be 27 out of 1,000.
Okay.
So then you subtract 27 from 1,000, and then that's that.
Ah, okay. So let's just see real quick with a calculator. So I get 147 times 3 plus 343 plus 189, and I do What's 1,000 minus 27?
973.
So there you go. So at least one you can do by complementary counting, and it's a little easier to do it by complementary
Yeah.
counting because you only have to do 1,000 minus 27. Okay, good work.